All right. Welcome to the 37th episode. I don't know if I still can say the 8th of January. Happy New Year.
Oh, yeah,
Happy New Year
absolutely.
to everyone.
Absolutely. Happy New Year.
Happy New Year, everybody.
Happy Year.
I think we can say these until the end of the year this year.
Yeah,
We have this exception.
we can let that ride for a while.
So welcome to the 37th episode of the IoT Happy Hour, first on 2021. And today we are very happy to release the first product, the first balena product, like physical product on the IoT Happy Hour, so the Etcher Pro. And this is why we have a lot of people today on the stream. Thanks for coming.
Where am I?
Yeah, we have the usual suspects more or less here. And well, we know Aaron already from Balena Hub episodes.
Yep.
But we have some new people here. Well, not new at Balena at all, but yeah. Please, Konstantinos, can you introduce yourself?
Hello.
For a second?
Yes. Sure. Yeah, I'm Konstantinos. I'm a product designer here at Balena, and I'm the project owner of EtcherPro, which is a product we are developing for the last almost 4 years now. And we are super happy that we released it this Tuesday. And yeah, and then we have Zisis and Alexis and Aaron from the EtcherPro team.
Hello.
Maybe a quick introduction from you guys.
Zisis, you want to go next?
Sure. My name is Zisis. I'm a hardware design engineer on Balena, and especially on EtcherPro device.
Cool. And Alexis, all yours.
Alexis, are you there? Can you hear us?
Yeah, I can hear you, but I hear you repeating everything 4 times. Like I have 4 echoes.
So maybe you have too many YouTube pages open.
Yeah,
No,
you have YouTube.
Oh, right. Much better. Much better.
This is the live problems. Yeah.
Yeah. Hello. Alexis. I'm working on the software side of Etcher Pro and Etcher itself.
Yeah, actually, Alexis was working on Etcher before Etcher Pro, and of course, he's responsible for the software side, so he knows a few things about Etcher.
Just a few things.
Just a few.
So if anyone has a broken SD card, broken USB, and so on,
yeah,
feel free to introduce
now you know. You can, you can
who
put
to
a face
bother.
to the name.
And Aaron, it's only been a few weeks, but you want to give a quick introduction and hello as well?
Yeah, sure. So I'm Aaron. I've been involved in Balena for only 2 months and a bit now, but involved in sort of the distribution and production side of EtcherPro and across the rest of Balena, but mainly been working on EtcherPro up till now. So yeah, helping to actually get it produced and get it out the door. So got a lot of work to get on with.
No small task.
No, not at all. Well, we've been talking about the term Etcher Pro, but perhaps we should actually let the audience know what is an Etcher Pro exactly. Yeah. Konstantinos, what are we actually talking about here?
We are talking about this device. So can you show my other camera? Yep, here we go. So I have this sweet device on my desk, and is a prototype, an EtcherPro prototype, fully functional, as we'll show later. And yeah, this is the device we're gonna talk about today. And basically, what it is a device that you can plug different devices or drives and flash data to it. So you can do SD cards like I have done here. You can do micro SD and you can do USB. So you can either on the USB you can use like USB flash drives, or you can actually connect devices like the thing, like here.
Wow.
Yeah, and we will do the live demo later on. So that's Etcher Pro.
But hold for a second, David. Do you think? Yeah, I think Konstantinos is showing what's on his desk. No?
Oh, wait a minute. Are we ready to roll into what's on your desk? I mean, technically, Konstantinos is showing what's on his desk.
Yeah, difficult to beat this one, right?
I don't think any of us can top that. Well, actually, Zesis probably has one on his desk.
Maybe Zesis.
Alexis might have one on his desk. But I know what's on me is my new "What's on Your Desk" T-shirt. How cool is that?
That's very nice.
My desk may not be quite as cool, but at least I'm dressed appropriately. I shot JR. There are.
They have a second one.
On your desk shirts now. Yes, there are. Konstantinos, I guess you already kicked it off. But I still think we need the official video, Mark.
So do you want the Christmas one? Or Christmas is over, right?
Well, Christmas is over. I think we better go back to the regular edition.
All right. So let's.
All right, everybody, get ready.
What's on your desk?
All right. Cool.
All right, Konstantinos, you have something else you want to show quickly? Is
there anything else?
I have some cool stuff that I will use later to disassemble EtcherPro. So this is a Chinese,
Is that the IoT screwdriver?
Yeah. I don't think it's IoT because it's not technically connected. But
that is the IoT screwdriver.
Right.
That looks like the one
it's just amazing. It's just amazing.
That's the one that Chris has.
Yeah,
I believe so.
IoT screwdriver making an early 2021 appearance.
I have a non-smart vernier caliper. It's pretty cool. And I have a blood pressure monitor. When I get upset with EtcherPro.
Can you hack that thing? Does it connect to the internet?
No, it's
when Zisis and Alexis get him very
piss
nervous.
me off, then always take my blood pressure.
All right.
Alexis, what's on your desk? If you can
actually, I have a new EtcherPro, which is just here.
Wait a sec, that I'm gonna
hold on. Yeah, zoom, make that larger. Yeah.
Better. No, it's worse with the light.
Okay, so this is an EtcherPro.
Yeah,
that
that's
doesn't look like an EtcherPro.
Oh, that's the screen. That's the main board, compute module here.
And some type there.
Except the EtcherPro.
So you just tape it all together and you're good to go.
Yeah, it's not even taped. It's just sitting there. Except the EtcherPro, I have some screens, fins.
Carlo, no hacking on medical devices, please.
Some scotch.
All right. Well, that's pretty much everything you need to assemble your own EtcherPro right there.
Yeah.
All right. Who's next? Zesis, you got anything interesting on that desk of yours there?
Not something interesting here. Just the board of the AP board.
Come on, so your new toys.
Well, wait a minute. What's behind you? What is all that?
Not something important. An oscilloscope, iron, hotels, air gun, multimeter, generator.
Wait a sec, but this is your house or this is the balena?
Where are you?
In house.
This is his cave.
Wow.
That's awesome.
Yeah. And a lot of boards and the sleeves, nothing else.
It looks cool to me.
That reminds me, David, that we have to celebrate one episode talking about the home labs that people have.
Yeah, we do need a home. Yeah, that's a good idea. We do need a home lab edition. I know I Shot JR has a pretty impressive setup over there. I see EtcherPro in the background too. Yeah, look at this subtle product placement behind Zesis. Look up on the shelf behind him.
Oh, sorry. Konstantin, and is the material on the desk, okay?
Is what? ESD. Nice. Yeah. Cool. Same color with EtcherPro. I don't think it's by coincidence.
Wow. Awesome. Well, Aaron, you want to go next? You have anything?
Yeah, well, I do. As I said, I'm still at my in-laws' house because we're having work done on the house. But I've got currently. Hold on, let me just. It's a bit messy, but you can see this is currently on the piano there where I'm storing all my electronics. So you can see a pin there and loads of other stuff. But at the moment, what I just arrived today was this, which is it's quite an old kit, but it's the AI kit. Well, I say it arrived. I dug it out of storage.
That's okay. What is that exactly? I've seen that term, that name before, the AIY.
It's a Google kit. Basically, hold on. Where's the box? Yeah, so you can see on the box there, it's just like a audio board, and then it's got a speaker with it, and it's got a microphone on the board, and then you can just use it as like a Google Assistant type thing. So yeah, it's just a little Raspberry Pi kit basically, but by Google. Although funnily, Google I think are like shutting down their AIY department now.
Yeah, they're selling too many of those Google Minis.
Yeah, so that's it for me.
Cool. All right. Very cool. John, yeah. What do you have?
Well, I gifted some of these Echo shows this Christmas, and that was a hit. And as part of it, I added the Amazon The Ring device, which is a big honking thing compared to the old doorbell. And I noticed if anybody is going to get a Ring, be sure to get the wedge kit that comes with it, because the wedge, we have siding on the side of our house, which is at like 80 degrees. So you have to get this wedge kit so that your Ring device doesn't point at the sky, and instead points. But it was a hit. So now I can say, Alexa, show me the front door.
Okay.
It's a little blurry, but there it goes. It's yep.
Wow.
But like I say, if I didn't have the wedge kit, I'd be seeing that. But it's amazing the sensitivity. When we were doing Alan Boris's Open Data Cam, I had a similar view, and the Ring is very sensitive to basically any object. So it's its own built-in AI of recognizing things is pretty interesting, and so it was a hit. My wife is pleased, and I can also use it now I can not only talk to the front door, I can talk to her in her office downstairs.
I got one of those. Yell? Why don't you just yell as loud as you can across the house?
Any reason to not have to stand is apparently a good one.
I got one of those doorbells, and it basically, can you on the Ring? I've got the Nest, but on the Ring, can you say you can put people's names in so it can recognize their faces?
Oh, I haven't tried that.
Right, okay. Because on mine, I've done that, but like the AI isn't very good because it just thinks everyone's me. Like Deliveroo drivers, it just says like Aaron Shaw's at the door. Definitely not. But yeah.
Yeah, it has a feature. When I first set it up, I'm like, it's not ringing. It's not ringing the doorbell in the house. It's ringing every device that I have. Wow. And there's a little setting in there that you just say, toggle it to say manually ring. If you don't do that, it won't send the signal through the house wiring. It's like, did I not wire it right? What's going on? But there's an amazing array of settings in there, including quite a bit of privacy stuff that you can do, which is pretty cool.
Cool. Awesome. David, what's on your desk?
Well, I also, as you know, am a very skilled hardware hacker. So let me switch to Blurry Cam. Trademark Blurry Cam. And you'll see here that I have a Raspberry Pi case. This is a normal off-the-shelf official Pi 3 case. And what I did was I drilled a hole in the top of it.
Nice.
You can see it. I drilled it with a drill that is a electric device that I plugged into the wall and made use of. So and then I just simply attached the Pi camera to the back of it with
This is
some
IP69, right?
electrical tape. So there you have it. That is a hole drilled in plastic and some electrical tape. Yeah, you guys think you guys are hackers? that's my hacking for the week right there. Sahaj is already asking, does it still work? So I don't know yet. I don't know if it still works. I'm sure it's probably dead, but we'll get it plugged in and we'll see.
And
So,
what are you gonna do? Are you gonna do this bird nest project that I shared with you?
No, actually, I was thinking about, and I see AB is on the stream also. I'll have more information on this maybe next week. Abhijit is a community member out of Dublin who has been doing a lot of work on the Always AI stack. Let me switch my camera back to me. He's got a project that he's putting together. Actually, I will leave that camera on for one more minute because I have my Pi Plus NCS stick here ready to go as well. And he's working on a project that's doing package detection. So when Amazon drops off your package at your front door, he's got some AI models trained on what essentially are boxes. And the camera detects whether a box is present or not present in the frame. And it sends a little MQTT message over to your phone as well. So I'll get this all properly documented and shared with the community and everything. I guess that's more of a tease for coming soon. But that was the that was the reason for drilling a hole into the Pi case.
Actually, my Christmas has been very excited about this glitter bomb by Mark Rober. Have you seen the video? So he was...
Yes, I saw that. With the four,
he was very tired.
4 cell phones in it.
We will share later the YouTube video, but yeah, that's
awesome.
So that's similar to what you...
So I was talking about the high key. All right, hold on. I'll switch my camera back. I am looking at the clock and we need to get started.
Yeah,
I'll switch my camera real quick. There's one other device on my desk. This thing back here is a 96 boards device. Let me see. This one is actually a couple of years old. It's pretty dated at this point. But you know, I like to hack Balena OS to get it running on devices. And this is a cool one. We can talk about this on an episode where we kind of dive into what it takes to add board support. This was an easy one actually because it's standards compliant, and we can, you know, have that discussion some other time. But so that's now running Balena as well.
Cool.
Yep.
I think we can say it's still working.
Yeah. The device is about 4 or 5 years old.
Let me show you what I have on my desk, and let's jump into Etcher Pro. So I had a Secret Santa. Thank you, Aaron, by the way. So I got this amazing Pi Supply toy. It's a buggy car with micro SSD by BBC. Microbit, sorry, by BBC. Yeah, looking forward to play it with children.
Yeah.
Thank you for sending. And I have a question for the community. So I had to remove for a project that will come to IoT Happy Hour soon. I had to remove this black element here, but I made a scratch with my screwdriver, removing the element. And I don't know if I would have killed any bus. What do you think? So I open a poll on the chat.
Looks like you may have gone through some of the traces on the PCB.
What do you think? So
I don't know. I don't know if that's going to live.
Exactly. Make your bets.
Were you using the IoT soldering iron on it?
No. I needed to remove the element. So I used a screwdriver, but with too much energy that I made that scratch.
You were channeling David.
Yeah, I mean, that's what I would have just taken a hammer to it.
All right, but it's time to jump again to Etcher Pro. So, hey, why do we have Etcher, or why do we need Etcher Pro at Balena? Constantino.
Good point. So I need to start a little bit earlier why we built Etcher. So let's have an example. If you have a Raspberry Pi and you want to load any sort of OS on it, so if you want to use it, you need an OS on it. You need to flash the OS image on an SD card, like any SD card, micro SD actually, and then plug it to the Raspberry Pi and then take it from there. And if you know, we have balenaCloud. So balenaCloud is an online platform where you can create a fleet of devices. So you can have hundreds or thousands of Raspberry Pis as a fleet and control them from there. So in order to put the devices to the cloud, balenaCloud, you need to flash software on them. And then we realized that there wasn't a good tool that can do that. And obviously, you can think that that's not our problem because like we are creating a platform to manage a large fleet, but obviously it became our problem since people had friction flashing software on their devices. And then like what we've done is that we designed a very simple application, which is Etcher. It's an open source application that basically you choose what you want to write and where you want to write it, and you just flash it. And it's not only that you flash it, it also check if what you flashed was flashed properly. So that was a great hit, and today Etcher flashes almost 2 million cards per month. It's very, very popular.
That's
and
awesome.
then, so that was, it was a great solution, but essentially we solved only half of the problem because still you couldn't scale. So we solved the software part, but there wasn't a nice way to plug multiple cards or multiple devices and flash software to them. And then, of course, you could use a USB hub and plug multiple cards and then do it as such, but it would be very, very slow. And on top of that, you have an extra issue that say you're flashing 10 cards with a USB hub. If one is problematic, which is not, it's quite common for SDs to have issues, then you don't know which one it is. And then you need to go and flash one by one until you find the problematic one and take it out. So that's another huge UX issue. So it was clear that we needed a solution for the hardware. So, like necessity is the mother of invention. So we thought, okay, let's go and build the hardware. And I can take you through the journey of how we designed this
When that
product.
happened, when did you release that you needed like a hardware to help?
Like about 4 years ago, almost 4 years
4
ago.
years ago.
Started. Yeah, we were super naive. Now I can tell, and we thought that we can have a product on the market in 6 months.
Like the EtcherPro that we have today, you thought that 4 years ago?
No, not the one we have today. But we thought we could have a product in 6 months. It just took us a little bit more. It's not a huge deal.
6 times
all right.
more.
Actually, I think it makes sense to share my screen just to show some visuals. All right, I'm sharing my screen. Actually, wait a second. So now it will be really interesting to learn about the journey that you why it took us so long. All right, can you see my screen?
Let's get it added. I'm grabbing that URL that you are looking at, and I'll drop that into chat for folks.
That's a blog post I wrote like a year ago or probably more, and it was the journey, that journey. Yeah.
Maybe zoom in a bit.
I'm going to make the text a little large. Yep, there you go.
Okay, so as I said, we were a bit naive, and our initial idea, and that's why we thought we could go to the market in like about 6 months, was to get ready-made components off the shelf and put them all together. So here we have an Intel App Squared, that's the processing module, a screen, a few hubs, and a few USB card readers, and put them all together in a case, and that would be EtcherPro. And then about the case, this is my very initial sketch on Etcher Pro. So the idea is that we wanted a device that basically there is a rectangular part where you can where you have the slots, and there is the triangular part where there is a screen, and we needed a large screen for Etcher, which is software I mentioned. And just to be clear, this is how Etcher looks today. This is the software I'm running on Mac on my desktop. And again, here you choose the software you're going to flash. Here you choose the drive, and then you flash it. Okay, so you wanted slots to plug the drives, and you want the screen for the UI. And then the reason that this is rectangular and this is triangular is so that it's stacked. So you can stack multiple devices, and that means that your rig can be extendable over time. So you can add more EtcherPros and flash multiple drives. And then this is the first render, right? So the so-called cheese slice. It's the very first render of how that could look like. And as I said, the idea was to grab all these components and then put them in a case. And here's the first actual prototype, physical prototype, and it's made out of cardboard. It's purely fake just to see how it looks like. And this is a render of the first design. So the question was, we had a few problems to begin with. One was that we couldn't start with a huge amount of device, like go to production, say with 2,000 devices or 5,000 devices. We were thinking like 200 to 500. And this is, technically, this is prototyping amounts, like nobody will take you seriously for production. It was a little bit difficult on which approach we should take. And we thought to start with sheet metal. This is a pretty common technique. Basically, you know, computer boxes, car parts, things like these are made out of sheet metal. And the idea is that you get a flat sheet of metal. And let's go to the Fusion 360. Actually, I'm getting a little bit of background noise. I'm not sure where is it coming.
Sorry, that might have been me.
No worries. Okay, so yeah, so basically you take a flat sheet of metal, so that's the design, you cut it out either by laser or by water jet, and then you fold it, and you get this frame, and then you just weld it on these edges. So this is the initial, that was the initial frame of Etcher Pro. And then in order to make that quite affordably, for the top and bottom, we would use flat acrylic sheets. The problem is that the acrylic was fairly easy because you get the flat sheets and then you just laser cut them, and that you're done basically quite affordably. The problem was on the metal frame. Metal bending is fairly inexpensive and straightforward, but our problem was that we had these large radiuses all around the device, and it's totally doable, but it's super expensive to achieve this with a reasonable consistency. So it was clear that there's no way we can take that route and go have an affordable device and go to the market with it. And then
so
the next step
of the project, Konstantinos, you had like a requirement about the price of the product, so to take these decisions.
Yeah, very good point. Very good point. Yes. So we said one of the, like in the manifesto of the project, we said that our device needs to be affordable, and what affordable means for that kind of device was about $1,000. A device that costs $1,000 can flash 16 cards, and the minimum average speed is 45 megabytes per second. That was we had to hit all these in order to say that we can go to the market. And actually, one of the reasons that it took us so long is to be able to have a profitable device with a price tag of $1,000. And indeed, the profit on Etcher Pro is not huge, but it's good enough to basically to go to the market. So yeah, the next one was, okay, so the problem was we couldn't manufacture the frame. And the other problem was that because you have all these hardware, that somehow you need to secure on the device itself, which is another problem. And then we use multiple sheets of acrylic and some weird jigs and things like this. And then it was getting too complicated. And it was clear that we need to change either the design or the manufacturing method. So basically, we said, why don't we do something like either 3D printing, injection molding, or some sort of casting, resin casting. And 3D printing, it would take a huge amount of time to print this device because it's fairly large and it would be expensive. Then injection molding, it would be super expensive to begin with the molds because, again, you need large molds, so we couldn't pay for that. And then if we do resin casting, which we tried at the time, we tried that for fin, but for the fin case, but fin case is way smaller, and it worked well. So we said, okay, maybe that could work. But again, the clear problem we had was that the device is fairly large, and these methods, they would be either very expensive or it couldn't be done nicely, at least. But we also made some changes. Sorry, that's a nice picture to show also. This is the metal, sheet metal EtcherPro that is, looks a little bit like steampunk. Anyway, yeah, but we thought that instead of having all these flimsy USB hubs, what about designing a PCB that technically it acts like a large USB hub and has all the ports at the right place, and then you can connect the Intel App Square directly on it. And for one, we couldn't hit the speed with this approach, but also we had the thermal issues with the Intel App Squared, which is, if you just check the size of the heatsink that it has, you can understand. So this is the bottom. The whole bottom is a huge heatsink, and you can understand that it gets fairly warm. So then it was clear to us that if we want to go to the market, we need to step up the game, and that meant that we need to take product design, the mechanical design, into another level and take it seriously. But also that meant that we understood that we need to take the electronics designs and have them in-house. And that's where we hired Zisis. And he started working for us. And this is the result after that. So Zisis, do you want to give some details?
Sure. This is the first version of the Etcher board. It's powered by a 24 voltage DC external power supply. The architecture of the hubs, there are two trees, let's say.
Here.
Sorry?
Yeah, so no, I was saying that the trees are left and right. So here's the middle, and then you have left and right.
Okay. Mm-hmm. Each tree has two USB 4-port hubs as a child connected to another one 4-port hubs, let's say the parent hub, and connected directly to the computation module. The computation module based on an IM-X8 processor. Also, we had added two Ethernet ports on the board for the daisy chain. On the top of the board, you can see some PCA sockets that we are inserted the card readers. The card readers, this is the card readers. We have some chips that we can drive SD, micro SD, and the USB device on this card, one each time. And those card readers inserted to the PCI sockets. It isn't a PCI bus, it's only we use as a connector the PCI socket. And we have a MIPI 2 lanes adapted for Raspberry Pi display. So about the results from the first prototype, we did not achieve the speed, the writing speed, the specification. Someone can ask me, using two USB 3 buses shared in 16 drives. Yes, sometimes the theoretical calculation are not the reality.
Yeah, exactly. That was the main issue. Is we realized that the speeds we were getting, the bus speed we were getting from IMX8 was significantly lower than the theoretical, and we wouldn't be able to hit the 45 megabytes per second mark.
Yes, also we have some thermal issues on the DC-DC converters on the board, because we had to support current requirements for 16 USB that we had on the slots. And also the board was too expensive to go to the market. And this was the first, let's say, version of the board.
Yeah, it was clear that there was no chance to go to the market. Even if we would scale, we wouldn't be able to hit $1,000 price tag. So again, we had that it was clear we need to change the electronics, and let's go and check what we've done on the product design. So as I said, we tried sheet metal, it didn't work. We thought injection molding, it was too expensive. Then the resin casting wouldn't work because of the size. 3D printing was slow and expensive. So we needed another method. And the other method we thought of using was vacuum forming. So vacuum forming is a popular method for to produce forms that are fairly large. So you can think car bumpers, things like these. That it's you need a large shape that is not 100% accurate. So the vacuum forming doesn't have the accuracy of the injection molding, but the idea is that you have a mold. So in injection molding, just give an idea. Actually, where's my camera? Yeah, can you show me?
Yeah.
Thanks.
Yep.
I will show with my hands. So basically, injection molding, you have two metal molds, and then you basically close these two molds with that has the shape of what you want to produce, and then you're injecting inside, you're injecting whole plastic that goes and fills everything. And then when this thing cools down, you open it, and then you have your part. And most things, if you look around, most things are produced with this method. And it's fairly inexpensive when you go to scale. The problem and the expensive part is producing the molds, the metal molds. Now, in vacuum forming, you have only one mold that could be a female or male. It depends on what you want to produce. And then you have a flat sheet of plastic that gets fairly hot, and then it goes above the mold, and there's a system that sucks the air out, and therefore the hot and malleable plastic is forced to go around the metal mold and take its shape, basically. So you can understand that the side of the plastic that touches the mold is very accurate, and then you have the other side, you have a little bit of fluctuating thickness. So that's vacuum forming. So let's get back to sharing my screen. All right. Cool. So, okay, it was clear by now that we either need to find a promising production method and design for this method, or we should change our design, basically, because the huge mistake we've done is that we start with an initial design and we were trying to figure out how we can produce it rather than try to see how we can use the tools that are available to us, basically. So we said, okay, basically, let's go vacuum forming. The simplest design you can get, let's get a square, like rectangular design, two pieces, top and bottom, and maybe use a metal leg or something to elevate the design. So again, these serve two purposes. One is that the device has a little bit of angle, so it's more ergonomic for the user compared to be completely flat. And then you can also daisy chain it, so you can stack multiple devices. And here you can, for instance, flash 32 devices or cards. So that was the initial thing. Then, yeah, this design didn't look very attractive to us, and we were thinking how we can work with this method and get something better. So what we thought of doing was to extend, if you see the yellow lip around here, if you extend that lip until it meets the desk, then you can start approximating the original design. So this is the result. So basically, you have the same top, let's say, and you just extend the sides until they meet the desk. And then for the bottom, you get similar side, a little bit more three-dimensional. We added a few more features. And then this is the device, potential device anyway. So a few interesting things here. One is that we, from the get-go, we were sure we want to do daisy chaining, but in order to daisy chain the device, you need some sort of cable from going from one device to the other. That could be, in this case, it's USB-C, but it could be, USB-A, or anyway, USB protocol or Ethernet. Today's device is with Ethernet. And initially, we thought of having the power supply externally, to have external power supplies. And when you have, for instance, 5 devices that are daisy chained, you will need 5 external power supplies. That's all doable and fine. However, it's a little bit messy, and you need to deal with all these power supplies. And then the user needs to find the right extension leads and everything, so it doesn't overload the system. So basically, we thought, how can we solve that problem so it's easier for the user to have a nicer flow. So basically, we used an internal power supply, and this is why you see this this side protruding here. So here it goes, the power supply, and the device now takes AC power instead of DC, makes the conversion internally, and then feeds the AC as output as well, which means that every device can be daisy chained both for data and power. And just to show you what's the result of it in today's world is this one. So here's the input. So you have data and power input, then it goes through the power supply and it feeds the PCB, and also continues and chains to the output. So the next device can take, this is the power and data output that becomes power and data input for the next device.
And the maximum of 10 is for electricity reason, or
yeah, exactly. No, this we could do more, but just to be safe, because we are not, like, it's difficult. It's purely a certification thing, and it's difficult to know what you have in your system, what else you have in your system. So in order to not overload your network, your power network, we thought that 10 is a good amount of devices, and it's pretty much the consumption would be equivalent of a vacuum or something like that, like a large consuming device, or I don't know, washing machine or something like that. So it's reasonable. I'm talking about the total, right?
Okay.
So yeah, that was the design, and we had a few issues with this one, and the number one issue was that I explained how the vacuum forming works, but I need to explain how you get the trimming around. So basically, once you vacuum form your design, right, let's see, let's show some visuals. So these are the molds for the vacuum forming. And once you vacuum form it, then you need somehow to go and trim the plastic around, because you can imagine, let's do, find an actual image. Yeah, maybe something like that. Oh, that's better.
Oh.
Can you see that?
Mm-hmm.
So you have your what?
Yeah, no, I can see how it leaves the rest of the plastic around it. Yeah,
Exactly. So the sheet remains around the part. So basically, you need to get rid of that with high accuracy. So you need a way to go around and trim it on the trimming line. So you do that with a robotic arm, a CNC robotic arm. Basically, you have after you vacuum form, you go with a drill bit and then you trim around, and then that's how you get your part. So
I have a drill.
you can do CNC. So you have an arm.
Sure.
Cool. So yeah, the problem was that we wanted a way to create slots as well. So yeah, the drill bit goes around and it trims the device and everything is fine and looks good. But when it comes to these tiny slots, it means that you need to change the drill bit and you need to go very slow, because if you go faster, then you will break the drill bit. And because you're going slow, it becomes very, very expensive, and the result is not amazing. So what problem number one, despite that in principle that method is affordable for small bats, it becomes expensive because of these features we want to add. And the other problem was that because somehow you need to attach these two parts together, right? So the device is secure. The standard solution that the manufacturer suggests is to add screws all over the place, as I've done here. And this is also expensive because you need someone to physically go around on every hole and add a nut on the inner part, so the screws can thread somewhere. So two fairly large issues. So how do we solve these issues? The idea was to basically trim whatever we can trim on the device naturally, whatever is easy for the CNC machine to cut naturally. And large openings are fine. Again, as I said, unless you go on a tiny detail or you have you need to use very small drill bits, you have no problem. You use the one single drill bit to trim off the whole of the device, and this is how you reduce cost. But the question, of course, is then, okay, how do you expose the slots? How do you create the slots? If you remember earlier, I said we explore injection molding. That was fairly expensive. However, if you want to produce a small part, that means that you need small molds that are affordable. And that was the idea. So cut large openings, that these are low resolution openings. And of course, this method, vacuum forming with CNC, is, you can think of the CNC trimming is almost a 2D thing, because it can just cut, it cannot add features. But for the card readers, we want to have some three-dimensional shapes in order to work as a cover for the electronics and host them nicely. So for this reason, we could have a small and very accurate mold that could be injection molded, fairly inexpensive. And with one mold, we could produce all 16 card slots, basically. Yeah.
That's really smart.
It will become more smart. It will become more impressive, because I will go a little bit to design thinking, yeah, basically this is a design thinking loop, which is a constant loop. You start with defining your problem, then you empathize, then you go into ideation, then you prototype, and you test, and you take all the loop all over again. And I have here, I'm trying to illustrate the divergence and convergence idea. So basically, on every step, that works as a heartbeat, and the whole concept is very similar to what we call loops in Balena. So in every step, you create options, and then on the next step, you narrow down. And it's a system we use all the time. We use that for the screens, for the different MIPI and USB protocols in a number of places, but we weren't sure what's the right way to go. We were diverging, so we were creating options, and the next time we were converging. However, despite we were converging, we wouldn't throw away the options we created, and this is technically what happened with the injection molding. So it was, at some point we diverged, we went to injection molding. For the time, we didn't consider it, but then we used it later on. And then another very interesting point is undesign. So undesign is a very important step of, probably the most important step of design, which means that it's very important to take a step back and remove all the unnecessary components from your design. And this is not only for aesthetical reason, but it's also for practical reason. Basically, by removing complexity, you are adding more features, as you will see in a second. So, as I said, with the vacuum forming, we had two issues. One, definition. So we solved definition with vacuum forming. And the other was, how would you attach the bottom with the top, the internal with the external shell? So in order to do that, since we are producing these nice plastic parts, why don't we add some pillars that we could use to insert some nuts, and then that's how we could do the whole assembly, as you will see in a second. So basically, this is a double purpose component, because it serves as a cover for the electronic, but also as a mounting point for the bottom to attach to the top. And then you see also these nice little flaps, and these are where is the PCB? So this is the PCB. So if you imagine in the assembly line, when they're trying to put the PCB into the top part, somehow all these 16 card readers needs to be perfectly aligned in order to go to the correct place. And by having these flaps, they will help the card readers to auto align into the right place. So,
really cool, man. That's very interesting.
And yeah, that's the today's design. And these the plastic parts, the injection molded parts, get welded to the vacuum form. And I want to show you how everything comes together. All right, again, so this is the card reader, and then the plastic part works as a cover, and then here they get welded. And here you have the different layers. So again, outer shell, cover, card reader, PCB, bottom, some standoffs and screws. And then here how it all comes together. I guess you see the GIF, right?
Yeah.
Cool. So, of course, you would say that, but now you're attaching the device only on the upper side. So you need a way to secure it on the bottom side too. So in order to do that, we thought of adding a peg that then the bottom part could attach to. And I will give you a better look of that. Right. So you have this on the bottom part, you have these openings, right? And then on the top part, you have these pegs that are attached here. And basically you just push the bottom part to the top part, and then you close the case and you just secure 4 screws and you're done. So apart from being a nice and slick solution, you can imagine how much time it saves in assembly line, how much less it costs because you don't need to add extra components. And on top of that, I want to talk a little bit about the little magnet here, because again, as I said, on the undesign stage, you're trying to remove complexity and have components serve as many purposes as possible. So this little plastic, apart from working to attach the two cells together, it also hosts a magnet. And the reason that you need to host a magnet is because if you want to daisy chain, if you want to daisy chain, you need a way for the two devices to be attracted, right? So that's going to be another interesting point. So we use magnets, right? So of course, the initial idea was to put some magnets on the front side of the device and some magnets on the back side of the device. And then when, of course, the two different devices are approaching each other, they would be attracted. Now, the problem is that in assembly line, you need to make sure that the magnets would be properly oriented. Otherwise, instead of attracting, you will have the one device repelling the other, right? So how can you make sure that the device would be indeed, the magnets would be indeed installed properly? And you could have a jig with another magnet that, you put it in place, and then you have you install the magnets always in the correct place. But again, you cannot ensure that the magnet will be properly installed. And then when you're doing the Q&A, then you need to check that as well. So it's an extra step and it's an extra complication. So how can we remove this complication? In order to remove the complication, the idea was to have magnets only on one side of the device that you can pretty much put anyway, because the polarity wouldn't matter anymore. And on the back side, that we need a sticker, produce the sticker out of metal, which of course is magnetic, and therefore it would be attracted from the front side of the following device. Does this make sense?
Yeah, absolutely.
Yeah, I'm following you. I mean, the whole process is definitely.
I don't see enough excitement. That's why.
Well, so here's the thing. I definitely took for granted how much effort goes into the design of the physical form, the shape. I mean, obviously, I understood the engineering effort required to create a custom PCB. I know that, but I did not give as much thought to how hard it is to make a physical design like this. It's crazy. I mean, when we saw, I see Sahaj here's comment, came for the demo, but staying for the production process. This is amazing to get this kind of insight. So with that said, I am looking at the clock because we're already at the top of the hour.
Go ahead.
Well, so I was going to say, and Alex, it's the case that killed us. Yeah, I had no idea how much thought and effort went into the physical formation of the product. So it's fascinating. So I'd say this, looking at the clock, I know that some folks in the audience will probably need to get on to their next calls, or if they have meetings or, other obligations. I get that. But if you want to go, we can probably run over, we don't have a hard stop.
I think it's worth it, since anyway, we can, this is recorded anyway. I think it's worth showing some extra cool features of the product and the demo, of course, which is very important. Yeah. And we definitely will run late.
Yeah, no problem. AB product design is amazing. Yeah,
absolutely.
So, I mean, obviously, we don't want to run all day. I get that. This is not a release party. those we have, a good.
No, I try to keep it compressed.
But what I was going to say is, let's continue on. I don't see any point in, some sort of a hard stop at an hour. That doesn't make any sense. Let's keep going. And, just be mindful, of course, of the time, and we're fine.
Cool. All right. So next cool feature. Here again, the nice way of having the cables tidy, and of course that's why on the case you have on the legs of the case you have these nice openings, so the cables can be passed through for the next device. And let's talk a little bit about the Ethernet, because this is a very, very nice and interesting solution. So the initial way we thought of exposing the Ethernet was to have a little PCB that is panel mount. You attach the Ethernet directly here, and then somehow you wire it to the PCB. But this solution is a little bit more expensive, plus on the assembly line, it's an extra step because you need to attach the panel mount into the case and then wire it to the main PCB. So one crazy idea was to have the PCB extending with these little flaps that expose the Ethernet under angle, because that's the angle of the PCB. Unfortunately, it's not easy to have a PCB that flexes here. I mean, it's possible, but it's very expensive. And then have the little adapter, the yellow one, that will cover the gap and will expose the port nicely. And this is what we've done. So back to Fusion 360 and the bottom, and you see that this angle, it's not too bad actually, because the cable will follow the natural angle of the backside of the device. So it actually worked pretty fine. And it was a crazy idea that, initially when it was suggested, we thought that it's not going to work, like it's going to be terrible, but actually it worked great. And it saved a lot of time in the assembly line, and again, reduce the price of the PCB. But now I want to go back to the electronics design and have this talk a little bit about the cool stuff we've done on the final PCB, which is this one.
Mm-hmm. So after a lot of time of working for improvements test, and a lot of prototypes, the final board, we add the PCI to 4-port USB hub connected directly to the computation module. All of the 6 4-port USB hubs dropped it and replaced it with 2 6-port USB hubs connected directly to the computation module. The redesign all the power on board distribution to work at 5 volt. The PCI socket changes with header pendant socket on the main board and on the slots without any effect on the speed performance. And also a 4-lane MIPI port added to support a multi-MIPI displays, not only the Raspberry display. The result of this board... sorry?
No, that's on the back. The connectors are on the back. Yeah, that's also for the assembly. For the assembler, it's more convenient for the assembler to connect.
So the results from the board, the write speed up to 55 megabytes per second. We can guarantee 52 for 60 cards at the same time. No thermal issues at all. On the board, current consumption reduced about 30%, and the cost from the old board about 35 to 40%. Kostadine.
Yeah. So you can see again the whole mentality was to remove complexity, but also like by removing complexity, gain more features. So the PCB became way cheaper, but also way better. So you don't have thermal issues. The actual electronics are faster. You get more out of it. And let's see what other cool features. Yeah, shall we talk a little bit about the software side and maybe have Alexis talk a little bit about the issues we faced and the nice challenges?
This is what I wanted to ask. So this is running like the Etcher software that we all know, or how different is the software running on the EtcherPro?
Yeah. It's running the exact same Etcher than anywhere else. We just added some tools around, like for example, for configuring your Wi-Fi connection, or saving in the screensaver. But it runs the exact same Etcher that you can run on your laptop or desktop computer.
Yeah, that was a good example of short-term pain, long-term gain approach, where initially when we said, okay, we're going to have one application that runs everywhere, it was we start saying, okay, how is this possible? On Etcher Pro, we have this and that, and the screen and the sleep and whatever, and the LEDs and whatever that's that. But we took the hard decision to say that we won't diverge. Basically, we won't create two applications, one for the desktop and one for Etcher Pro. It's going to be one that is going to be extended, and Etcher Pro is going to be the hardware that it will take full advantage of the Etcher application. So, for instance, the LEDs, the reason that you cannot have them on your computer is because you don't have LEDs on a hub or whatever that can operate. While on Etcher Pro, this is designed to take advantage of that feature. But for instance, multi-writes, we didn't keep it exclusive on Etcher Pro. We support that on every platform, basically.
And this is the balenaCloud device. It's a Balena device?
Yeah, what are we looking at here on screen? I see
Alexis, do you want to...
the dashboard.
Yeah, I can try. This is the device that Konstantinos showed you on camera. It appears on the Balena dashboard. So it's actually very convenient because I can hack on it, open shells, deploy new software. So every time we had an issue with any device, I could just hop in and act like if it was near me. So yeah, Etcher Pro will be a balenaCloud application that we will manage and deploy updates with.
So that's interesting then, just in the normal balenaCloud model of, pushing updates out to devices. So the Etcher Pro sits on your desk and the application, it's running version, XYZ. As we continue to develop and add features to Etcher, you can actually push those out to Etcher Pro devices then?
That's correct.
Yeah, that's the idea, yeah. Of course, if you want to deploy your own application on your Etcher Pro device, you can reflash it and have your own application completely different if you want, or a fork of Etcher or anything. But
so when you buy
Etcher, sorry,
go ahead.
Yeah, like the main when you get your Etcher Pro, it has the Etcher Pro application managed by Balena. But if you want, you can have your own app or anything else on it. Like you can take ownership of the software if you want. But I guess that's not how most of the people will use it. Most of the people will just get the Etcher application and get updates.
Yeah, I mean, I'm sure that the bulk of users out there will, continue to use it, and it's the way in which it's. I don't know if I want to say intended, but as it ships, as it comes to flash up to 16 devices or daisy chain together. But it's good to know though that. Excuse me, that if they wanted to make modifications, I mean the device is hackable and they can go down that path if they want to. That's pretty cool.
Yeah, so the one of the great features of Etcher Pro is that it will get auto updates, which means that it will get better over time. So every time we deploy a feature, you will get that automatically. And of course, for free, since you own a device. But of course, we also support the idea that Etcher Pro is a hackable platform. And if you want to take your device and write a code that does something very specific for your use case, you're absolutely free to do so. And we do support that, which means that you can create a balenaCloud account and take it from there, deploy the software you want. Now, something else I want to add about the balenaCloud, because it's amazing feedback loop. I explained why we wanted to build Etcher Pro, but the reason we got very obsessed about the project is because it satisfied many aspects of Balena in general. So first of all, most people know that we have also the Fin, which is an IoT board, and we need Etcher Pro for our production line. So we need Etcher Pro to write software on fins. So we experienced the issue I mentioned about friction on flushing devices at scale. We had that problem for fin, and then EtcherPro solves that part of the issue. And then again, we developed the whole product through balenaCloud, and we're doing physical product design with a remote team, which is quite unusual, and we do that through the balenaCloud. Because, for instance, I have my device next to me and I'm working on it, and then if I have an issue, Alexis can just use this dashboard here and go and figure out what's going wrong, why my device doesn't perform the way I want to. And pretty much all the EtcherPro team is remote, and it was an amazing experience to use balenaCloud and improve it, because while we were using it, we found issues, UX problems that we work and solve that while developing EtcherPro. So it was an amazing experience to get into our customers' position and use balenaCloud as a product, from the user perspective, not from the developer perspective.
That's super cool.
Yeah, super cool.
And here quickly a nice. So this is again you see we are running Grafana. So this is the container, and Grafana is here, and we can see on EtcherPro the temperature, the performance, and everything.
Wow.
All right, shall we move to the actual demo?
Yeah, let's see this thing in action.
Yeah, maybe
I'm excited.
Let's do that.
We can have the demo. Meanwhile, you talk about the software, what's happening. And,
So
what do you want to demo first, Konstantinos?
Can you show my camera, my other camera, the EtcherPro camera?
No.
Looks like it's disconnected.
Yeah,
perhaps?
it looks like disconnected.
No,
I went to sleep.
Okay. Yeah.
Yeah.
It's back.
There it goes.
Perfect.
Make that. Mark, if you zoom. Yep, there we go.
Amazing. Okay, cool. So here we have the large screen, and then we have Etcher running, and then I have already plugged a few SD cards, and I will plug more. So you see the white light here is for the connected drives, and as I plug more drives, they get auto-selected. So I'm not sure if you can see it. It says the amount of targets, and then it keeps advancing every time I'm plugging something.
Apologies. I'm going to try to...
And now I have
18
targets.
Yeah, there we go.
And I want to use the flash from file feature, which is the highlighted one. So I have an SD. It could be anything. Here, for the example, I'm using SDs. And I have my source here. I'm plugging that in on the first slot.
So the first slot, it's always a source.
It's not, but it's not only the slot. It could act both as source or target.
Okay.
Right. So in this scenario here, when you have one source there in the left slot, you're replicating to up to 15 devices. But if you're flashing from a URL, in that scenario, you could in fact make that slot a target, giving you up to 16.
Yeah. Or if you have daisy chain devices, you are only sacrificing the first one as source, and the next one would be, of course, 16, because you only need one source.
Yep.
So anyway, so this is going to be my source. I'm going to flash from file now. So flash from file.
How do you send the file that you want to? So how do I send my Balena OS project to the EtcherPro?
You need to write it on any kind of drive and connect the drive here. This is one option. Later on, we will planning to do some cooler stuff. Ideally, like the dream, I'm going to describe the vision, would be when you're on balenaCloud and you when you want to add the device, you could flash with Etcher directly. And there you could detect an EtcherPro and send your image there, but that's like for the future. For now, you need somehow can we configure the source slot is a question. No, it's not configurable. I don't know if later on we see that it's a huge requirement, maybe we can do that configurable. The reason we only use the first one is just for convenience. So you always know it's the first slot.
Makes sense.
I'm going to choose an ISO file. Select. So now this is blue. It's not super clear in the camera, but this is blue. And it's on the first drive. And then I have 15 targets, and I'm going flash. That's it. Let's see what speeds will we get. So you need to trust me because I know you cannot really see the speeds, or
Maybe you can zoom a bit.
Yeah, I don't know. Are you able to zoom any further? We can't
a little
quite
bit. So that's going to be...
But, I mean, we can see it's working.
Yeah, it's nice to see the LEDs blinking.
It's working.
30-something megabytes per second.
It fluctuates a lot. Let's wait until the end.
While it's doing that, AB was asking the question, I suppose, if a slot went bad, then it would be helpful to be able to configure it. So, you know, knowing that underlying small PCIe carrier PCB, you know, if it failed in some way, I guess that would be helpful. But
yeah, I mean, that's a good point. That's a good point. Maybe for the future.
Yeah.
Ideally, we don't want that to happen on any device.
Sure. Yeah.
But yeah, you never know.
Makes sense.
Let's see.
Or if one of them did prove to go bad, I wonder how difficult, knowing what you showed us already, would it be to crack the thing open and swap out that underlying PCIe extension board just to repair the single slot. But I guess maybe that's a conversation for another day.
I have a lot of questions. Meanwhile, we are flashing and validating.
Yeah, sure. Go ahead.
So these for pre-orders, what's next? So maybe Aaron can talk about the production plan and distribution. What's on your plate now?
Yeah, sure. So I guess at the moment, as you said, we just launched the pre-order on Tuesday. So that's you know, a first big step for the team. So as Konstantinos said, it's been a work in progress for a long time. So it's good to get it out the door. And I guess my role in all of this is to help get it to that point. So yeah, effectively at the moment, we're doing a huge amount of sourcing. So we've got, you know, you can see from the bits that Konstantinos and Zisis and have just shown, like there's quite a few different parts to the hardware. So you know, obviously the big ticket items you can see are the display, the case, the power supply, but then obviously there's a lot of other smaller parts inside. So we've Andreas, who is at the warehouse, I think we might do some videos with him further down the line to show the actual assembly process. But he's got a lot of new toys arriving, cool stuff like that for the warehouse and assembly.
Oops, we are.
Are we losing Aaron? I thought maybe it was just me, but it looks like it might be.
Just to add,
that's okay.
Also for the assembly line, that we design the assembly of the product as part of the product design itself. So while we were designing, we designed the tools and every flow straight from the beginning, how we would like that to be done. And I think it's going to be very, very cool when we will have Andreas showcasing how we are doing that. And it's going to be one person technically in the assembly line that will do the work. So yeah, I think it's going to be.
We better get him prepared to show what's on your desk also. Now, he's been on before. He joined us for the assembly line of our Inky Shot project. Right. So we've seen his setup before, but yeah, we're going to have to get him ready. But yeah, we'll definitely do a future episode devoted strictly to that process. Absolutely.
Aaron, we lost you for a bit.
Yeah. You hear me now?
I think.
I don't know.
You didn't pray enough to the gods.
He did not say his prayers to the demo gods today.
Yeah.
So we have more questions from audience.
So the speed I'm getting, just the flash just finished. The speed I'm getting is 43 megabytes per second, which is not the ideal. Probably something is going on with one of the SDs. And it slows the thing down. It's still fast enough, but you know, like before I was testing in and I was getting 48. Anyway, we will see higher speeds in a second where I will try different cards. But yeah, we're already getting 43.
So that's an interesting point you raised right there. I want to skip real quickly, though. AB is asking, is the default Etcher program on our PCs, can it flash multiple SD cards using multiple readers in one go? And absolutely. Yep.
Yes.
That's... I can't remember if it was you, Konstantinos, that was talking about it, or maybe it was Alexis that had mentioned it, but some of the feedback loop of the product design, which was, we know we're going to target up to 16 devices, and rather than having two separate etchers, two branches, we wanted just one for simplification. So that feature actually got inherited into Etcher. So AB,
Etcher
if you've got multiple, go
Etcher
for it.
itself. The software became better because we did EtcherPro. Actually, the SDK became faster while we were developing EtcherPro.
Yep.
So what I'm gonna do now is I'm gonna choose. So I flashed an ISO file, and now I'm gonna do an image file. And we have a nice feature. That's what I want to showcase. This again on Etcher, not only on EtcherPro. We have a feature that's called trimming. And basically, it's a magical feature that Alexis wrote that makes the hardware faster than it actually is. Alexis, do you want to say a few words?
Yeah, it's not magic.
It's
really.
Are you sure it's not magic?
Now, if for raw disk images that have ext partitions, which is very common in IoT disk images, we can just skip the parts of the file system that are not used. So we ask the file system to trim itself, and it will discard parts of the disk image, saying that this part is not used. It could be anything. I don't care. So for these parts, we will just not write anything. We will skip them. And depending on the image, of course, we can get very important speedups. Because some images are small and expand when you boot the device the first time, but some images are like 16 gigabytes or 32 gigabytes, and most of it is free space.
Empty.
Some Android images, for example, and we just skip them, and we can go much faster. I mean, depends on the image.
Here, for instance, I didn't change the cards. So before we got 43 megabytes per second with the ISO file, and now with a image file, it's 153 megabytes per second. The effective speed is 153. So it flashes as it would flash with 153 megabytes per second. Because it skips that, so it's a great feature. And okay, let's do we have other questions? I will try to show
what I would like to see. I love balena fin, so can you flash?
Sorry, I will do. I can do that. I want to show another quick feature. So basically, just to have some fun, I want to do SSDs. So this is SSD USB. Just to see some super high speeds. So just to be clear, we say that the device can do minimum 45 megabytes per second as long as the cards support it.
I was going to ask that.
Yeah, if you use a slow card, you're not going to get it. And this is what's something that for some reason one card is slowing. So if you have, that's another important thing. If you have a slow card, it will slow the whole stack down because the flashing is synchronous. And that's the reason why I got 43 instead of 48 that I was getting before, because something like a card is, for some reason, getting a little bit slower. And we're actually planning to, after the flash, to show some stats on the individual speeds of the cards. So it would be very easy to see which one is the
this will be a good way to test your SD cards to see which ones achieve their maximum write speeds as advertised or not.
So again, flash from file, and then I changed the source to use SSD because, as you can think, as you can imagine, the source plays role to the speed as well because it's the reading speed. So I want to have very fast reading speed too. And most cards advertise their the reading speed, not the writing speed. So you may buy a card that says 90 megabytes per second, but their actual writing could be, I don't know, like 30 or 40. So that's why you won't get the best out of the product.
Yes, you need to pay attention when you're purchasing the SD cards to their write speed.
I'm going for the ISO file, which is the actual writing, so no trimming here, so no magic, and change the. Okay, so now source is the first one, and then I'm flashing to the second and third, and flash. and then it goes like 190, 200, 190. Let's see what we get the final. This is actual. This is not trimming. It's very nice. Very nice to see. Right, validating. You can skip well, I'm gonna skip validating. This is just check if the flash was successful, but it won. Like still, the flash is complete and it's correct, but we didn't just check if indeed the flash was correct. This is validation. So if you're in a rush, you can just skip it. Yeah, we can later we can recommend some as this for sure. So average speed 171 actual.
171.
Yeah, but of course, if you add more SSDs, it will drop because it's going to be shared, right? But so that's why I'm doing only 2. So we get the highest speed. So yeah, let's go to fins. Just wanted to show this nice high speeds.
That's really cool. Formula 1 SD card flashing.
I'm not sure if we will have the if we will wait until this is over. So here I have a fin. Okay, I have multiple fin actually with Raspberry Pi compute module on it, right? And then the Balena heatsink.
Okay, now that fin you have plugged in. Now wait a minute, you have that fin plugged into the source slot. So hang on a second. Why is it in the source slot?
I don't know. We'll see.
Oh, okay.
We'll find out. Okay, it doesn't matter. Like so. For the fin, I'm not going to plug 16 because it will take time to plug 16 fins, but it won't matter. The speed won't change because this is fin using USB 2. So anyway, let's say it's naturally slow. USB is naturally a bit slow, so you won't get the huge speeds anyway. So the speeds you will get with 4 is what you will get with 16. So let's go and check here. So what's going on is that you see this little progress bar, and the device is, it's gone already because the device needs to initialize when you plug them in. And then I have 3 features here so far. Flash from file, which I already showed. Then we have flash from URL, and for instance, I can choose, I have a preset here, or I can go and type a URL. I have a keyboard, which is one of the reasons that we chose to have a large screen. So I can type a URL, and I can use that as my source, and then I could flash 16 drives from that source. And the nice feature we have is that you don't wait until the image is downloaded. We flash as we are streaming, basically. And then the other feature that I will use now is cloning. So basically, I want to clone the first fin, okay, from the first slot to the other 3. So say I have a fin that has the software I want and everything, I can take that, plug it in, and clone it to other fins.
What?
Neat.
Wait, what?
Feature, right?
And wait a minute, hold on. That fin that is in the source slot, though, let's assume it's already attached to balenaCloud. It's a balenaCloud device. What's going to happen on device number 2, 3, and 4 there? Are they going to show up in balenaCloud as well then?
Oh, yeah, I think so.
Well, we're going to have to find out.
Well, we'll see because, yeah, it's not, I'm not using the balenaCloud image now. So
oh, okay. All right. No problem.
So basically what will happen now, I'm going flash.
Well, we're going to be testing that in the future for sure then.
The thing is that now that's going to be very slow. It will take about 20 minutes. And the reason is, one is that we are writing with roughly 15 to 20 megabytes per second. And this is because, again, of USB 2. But also, when you are cloning, we are copying the whole drive, the whole size of the drive, to the targets. So if you're cloning a 32 gigabyte drive, you need to wait until like all the size of the drive is copied, even if you only have a file in it.
Gotcha.
So we are
That's
copying
okay.
everything.
It's all right.
Well,
It's
sure.
understandable.
I just want to clarify that, because sometimes people are confused why it takes so long to clone, and it's because it copies the whole drive. So yeah, that was the nice feature I wanted to show. It's that you can clone devices, which is amazing. And we are also we have some people asking how they can flash compute modules, Raspberry Pi compute modules. One solution is to use a fin. The other solution is to use a little adapter we are exploring now, and you can connect again with USB. And here is again Raspberry Pi compute module with a heatsink, and you just plug it in and you use a USB cable, and you can flash. And we are also
what was that carrier? What was that small carrier you had?
We can share a link for that.
Okay, no problem. Was that the Gumsticks one? It looked like the Gumsticks compute flash.
EtcherPro Gumstick, yeah. EtcherPro Gumstick, yeah.
Yep, that's a good one.
But we are thinking also to produce a little adapter on our own. We'll see how that goes. All right. Do we have other questions? And do we have time? I would like. I'm not sure how we are doing with time, but if we are cool, I could do a quick disassembly of the device, if you think that's interesting.
Teardown? A live teardown?
Why not?
We have to have time for that. Absolutely, we've got time for that. All right, sure. So hold on. Let's look at the clock real quick. Yep. We are at an hour and a half. I certainly am okay. I don't know if other folks, even right here on our own panel here, need to drop. Mark, even if you need to get going, I can continue on. Not a problem.
No problem.
So
we have some questions.
There are a few questions. While that's
so maybe if you start disassembling,
throw the questions while I'm doing the.
Yeah. So the first one that we have not addressed yet. So we had the question about, do we have any recommendations on SD cards from Anuj? And I wonder if maybe we should do some experimenting or testing live, order in a couple different brands. We could even make an episode out of that, quite honestly. Konstantinos, is there anything you want to directly say about a recommendation?
Well, that's not definitely an advertisement. It's right. So what we are using, that's what we are using. So we are using, for instance, here I have one classic option is the SanDisk Extreme Pro.
Okay.
That does, I can hit the speeds we want. And it's the U3 option, class 10. And then it's a single row, right? And then...
Yeah, let's get the camera on. Yep, perfect.
Right, and then we have the other one, is the Lexar.
Lexar, yep.
Yeah, whatever, Lexar. No, it's not going to work. Yeah, whatever.
It's all right,
Lexar,
we can see.
32 is the 2000X version.
Okay.
U3 class 10. That's also fast. That's the usual cards we are using. Apparently because they are easy to source on Amazon next day. So
that's all right. Well, hey, that matters though. I mean, honestly, if you're deploying an IoT project and you need to hit a certain time frame, that's the whole point here, right? Okay, that card is easy to source and acquire, and you can literally write 16 at a time. So that's a valuable piece of information. All right, and then Amit is asking, can I add SD card in reader and write a total of 32? Meaning, can he add 16 SD cards and 16 USB?
No. Okay. So no, you can use one drive or device per slot, but you can mix and match. So you can start, with a few SDs, then a few micro SDs, and then a few USBs. That's not a problem.
Okay.
As long as you have only one drive per slot. That's it.
One drive per slot. And then, in fact, I see he simplified the question after that and said, can only one of the three slots be used or all three together? And so that's perfect. You got that one. All right. Next, what's the difference between an A3 or an A2 class of micro SD card? Do you happen to know that one?
I don't. You mean U?
It could be
Probably.
U. Oh, yeah. It could be a U. Sorry.
Yeah.
I know there is a U. I think I've even seen A1 or U1 maybe as well. I think that strictly is in
I don't
reference
remember.
to the speed, but I'm not
I think so.
sure.
Maybe this is. Do you remember?
No, because I did not remember.
Right. So now what I'm doing is I'm removing the 4 screws that technically hold the 2 parts together.
Look at this IoT screwdriver.
Oh, is he
cool
using the
thing.
IoT screwdriver?
Right. What else?
There
What
it
else?
is.
It's super cool. It's super cool. Basically, you just press a button, and then based on it has an accelerometer, and based on where you are tilting, it just starts screwing or unscrewing, which is amazing. It's super cool. All right. And then the device is now open. And yeah, so here you can see down here you can see the peg I talked about, and then the
oops, blurry. Now, perfect.
All right, and then as I said, you target these openings to the tabs, and then you just close the device. And here at the bottom, you have the power supply. It's a 5-volt power supply. You get the power in that goes to the power supply in, and then it also goes to the device out. So that's the AC, all right? And then from here, you have the DC going to the PCB. Now I will disassemble that.
Aaron is saying we need to do an iFixit teardown, submit it ourselves.
Yeah, that could be. All right, so overview. Here we have the PCB, we have a few standoffs, and then we have the screen and a little fun to keep things cool. I'm also gonna disconnect the screen and remove the So I'm removing the standoffs. So these standoffs essentially hold the PCB in place and also offer a place for the screws of the top part to be screwed in, if that makes sense, because it's like a sandwich design. All right, so we are done, and whoop, that's the PCB. Right, so you have the card readers with a header.
It's focusing on the back side still.
Don't let me down.
A little closer, there it goes. Yep.
Right.
Nice. So we have the USB card reader that this is designed with it's super nice with a header here. I keep losing the focus. Right, and the embedded LED right about here.
Okay.
Yeah, we can see.
Nice.
Yep.
And yeah, the PCB here is the compute module with a heatsink and the antenna, and of course the fan, because IMX8 is fairly warm and it tends to get pretty hot when you want to flash with high speeds.
You spoke earlier though about, as part of the iteration and product design cycle, you had an Intel up squared in there, and I mean, it sounded like that ran even hotter. So it seems like you made
it's better, but yes, exactly, it's better, but still. What else we could show? Yeah, here you see a few standoffs, the brass ones that are directly attached to the plastic part, the injection molded part I mentioned earlier, and of course you have extra few other pegs here that coming for free and we don't use, but that's not a problem because, as I said, we only use a mold for each part to reduce the cost. Yeah, I think that's pretty much it. It's a fairly simple design. After a few iterations, we ended up with a very, very simple design that it takes not too much time to assemble.
Yeah. Honestly, I mean, it is fairly serviceable. I mean, really all you did was remove a couple of screws and you were able to grab that PCIe adapter out of there. If one of them did ever fail, I mean,
it's not too bad to change, or say in the future, if we have another model that has, whatever, an extra feature or something like that, it's not too bad for the user.
It's not like taking apart an iPhone. It's like you just remove a few screws and that's that.
Yeah. It should be very, very quick.
Yeah. So, wow. All right. Anything else? Aaron is asking, show us the metal plate close up. What metal plate is he referring to?
What metal plate are you referring to?
You got it on there on that one. The the one on the back, the magnet one.
Oh yeah. Cool. This is the one. It's a stainless steel piece that has some decals engraved with laser, and it has this double functionality. It works as a label for the product, and it tells you, that here is the power and data out, and this is the power and data in. It has the logo, the certification marks, and everything, but also gets attracted from the magnets that are hosted in here when you are daisy chaining devices. Okay, so maybe something else I can quickly show without screwing this. So I have another.
He's going to get unplugged. This cord is
here. So this is a metallic
metal version.
Right. This is the metal grade. This is a special edition. This is a special edition plus a prototype. So here I'm testing different configuration of the LEDs. This is why I have the tape. But the reason I brought this out was to daisy chain.
Oh, wow. Too cool.
That's cool.
Yeah. That's it. Yeah.
Oops.
We lost the camera, but that's all right. We saw you made it just in time.
Right. Yeah, exactly. I'm out of battery, actually. So let's get to the actual thing. Yeah.
All right. Well,
just in time.
Anything else? Just in time. Yeah, just made it.
Do we have more questions? Anything interesting?
I didn't see any others roll in. I think we answered
Sahash
them
was
all.
asking if the Heatsink do not align with the airflow from the fan.
If what?
The heatsink fins do not align with the airflow from the.
Yes, that's a very good point, and it's you have a good eye. This is not the original heatsink we are intending to use for the product. It's another one that I use for prototyping, and we have a custom heatsink for that purpose, that the fins align with the airflow. That's the comment about. So basically, when you're blowing the air, if you have the fins perpendicular, basically it works as a wall. It needs to be parallel with the air so it cools down. It still works, but not as efficiently. And another, like for a future version, we actually would like to entirely replace the fan with a large heatsink that could take more space. It could be a large piece of aluminum that basically dissipate more heat inside the device, and in theory, it could replace the fan. But this needs more testing. And obviously, the reason that this is interesting is because the fan has moving parts, and it could be a point of failure at some point.
Right.
I mean, it's pretty common fans for computers, but if you have a passive way to cool a device that's way better.
Yeah, makes sense. Like the Pi 400 AB is asking. AB did have one question that we didn't speak to, but Aaron did answer. AB had asked, can we run this on a Pi 4, knowing that, of course, the Etcher functionality is already there? And Aaron had come back and said that you could, in theory, absolutely do the cloning and the fin programming on any platform. Again, because of the fact that we rolled all of the requirements for the Etcher Pro into the Etcher application. So yeah. Yeah, Anuj, do water cooling. That's what we need. So I think we got them all. Mark, did you see any others that I missed?
I don't know if Aaron wants to complement his because he was cut by internet.
You hear me now? Or?
Yeah,
Yes.
he's back.
Good.
So maybe you can explain if I pre-order today an Etcher Pro, what's going to happen?
Yeah. So with the pre-order, the first units were the special editions. So those ones are shipping out sooner. So they were 2 to 3 months. And then if you order one of the ones which you can get now, which is the blue one, that's the regular one, that will be probably 4 to 6 months. But we obviously hope to bring that in, but that's kind of what we're targeting. But obviously, we want to get these shipping as soon as possible. So as I was trying to say earlier, but got cut off by my internet connection. But we've actually had the 7-inch displays arrive in the port in Greece just today, I think. And we've got various other bits arriving over the coming weeks. So yeah, we're super excited to get them out. So as quick as we possibly can, really. But it just depends on a few factors of when we can get all the parts, and there's Chinese New Year in the middle as well, which slows things down a bit.
Yes, that's right.
I think it's worth mentioning we are fighting a last issue with the certification, which pretty much Zissis has already solved, or it's like 90% there, let's say. So basically we discovered some weird spikes on our PCB, and we now know where it's coming from and how we could solve it. And I think within a month or so we will be ready to go through the official certification.
What certifications is?
What does it need to?
CE, FCC. I think that's mainly it, right?
And ROS or
safety one. There's a safety one. Safety one is so you don't get electrocuted and stuff like that. Basically, the device is not dangerous, and then you don't have weird emissions that could be dangerous for the users.
Cool. And you're testing like daisy chaining the device, or just one?
Do they have to test? So when you take it to the test chamber, they test one unit, right?
Yes, they don't test the daisy chain, but it doesn't matter. It's like it's like you have multiple devices in the same room. It's the same.
Yeah.
Okay. Cool.
All right.
What else? What else are we forgetting about?
And then what about a special clear edition? What if I want one that I can see the internals on?
I'm not sure if it's easy to vacuum form. You definitely can injection mold, but it's not easy to vacuum form a flat, clear sheet. Now, what we tried, I was experimenting a bit on what the special edition would be, and I was trying different combinations of colors, things like this. So at some point, I tried clear injection molded inserts. So that would be the slots, basically.
Gotcha.
On the special edition, you see the dark gray ones to be clear, but that didn't look nice. Actually, it looked very cheap. Christmas tree version of Etcher Pro.
All right.
An interesting maybe point to mention for the people that are buying Etcher Pro is that you cannot turn off Etcher Pro. It only goes to sleep. so it's always available. You just tap the screen and it comes back immediately on to keep to flash whatever you want to do. And while it sleeps, it will run all the updates, software updates that we will do through balenaCloud. So essentially, if you want to turn it off, you need to unplug.
Gotcha. We had one last...
portable. I see. Yeah, it's not portable. Like, no. I mean, we have the space for a battery, but do you want to carry that stuff with you? I mean, it's
he might, knowing, yeah,
nice device, but
Sahaj probably
would. Examples.
Yes.
It's not too heavy. It's not too heavy, but it's large.
He's probably one of the few people in the world, but yeah, he might actually want to make it portable. So.
Why not then?
He'll have to do it. And then does it pick up where you left off when it comes out of sleep?
I mean, in the sense, like, it won't go to sleep if you're flashing. But probably if you mean keep the devices you selected before, like, remain selected, yes. It remembers that. It remembers the image you could probably selected or things like these, and the drives. Yes, that's a yes.
Yeah.
Cool.
All right. Well, I think we better cut it before we hit the 2-hour mark. I think we're probably, this is a special double episode, special welcome back 2020.
I think it's worth it.
Yeah, absolutely worth it.
We missed one for the new year, didn't we? So
yeah. We missed. We were gone for a week or 2 weeks actually for the holidays. So we had to come back big. But it's good. You're right. It's all the information is valuable, and folks can come and watch later, because these obviously get posted to YouTube. So no, definitely worth the time.
Next week we will prepare chapters so people can jump to the favorite section.
I've carried an entire server from there. So yeah, I'll carry it. Okay, that's kind of funny. True. But funny. So, all right. With that said, anything else, guys? Anything else? Alexis, Zesis, Aaron?
Not for me.
No.
Awesome. So keep working because we want to see the EtcherPros on our desks.
Absolutely.
Ourselves. I'm sure David will go on hiking with an EtcherPro. Flashing 15 SD cards next to a cactus.
Oh, I can only imagine. What do I need an EtcherPro for? Let me start thinking. I'll find a reason.
So thanks for this amazing journey and showing us the journey to release the EtcherPro. Why it took longer than expected? No, you said at the beginning that you wanted to do it in 6 months, and it took 4 years.
Yeah, it was a combination of things. So, like, to begin with, in the beginning we didn't realize how much work it would take, but also as we start developing it, we got obsessed with feature and spec that we want to release, and then it got more difficult to hit all the targets. Being the 45 megabytes per second on the speed, the $1,000 mark, and all having the same version of Etcher running on it, all that stuff is why it took us a while. And yes, thank you for hosting us. It was very, very nice, and very, very nice to see people asking questions and be interested.
Looking forward to invite you next time, maybe with certifications done, and maybe with a camera in the lab in Greece.
And I think
we'll do an assembly special. Yeah, absolutely. Well, his lab is amazing. I mean, like I said, he's been on before. We've seen. So we look forward. We'll have more episodes in the future as we get closer. And then I shot JR sneaking in one last question here about a mini version.
Well, I mean, you can do the DIY one and consider it a mini with USB hub. Raspberry Pi 4 and a USB hub or something. That's your mini.
There you go. Well, all right. So I think let's wrap it up. Mark, you want to hit the?
Let's say these, maybe, David. Let's say that.
Yeah.
That we
perfect.
have seen
Perfect.
an amazing machine.
It sure is.
And thanks for coming.
Yeah, thank you guys.
Looking forward to have you next time in a couple of months, delivering first units and maybe having some community members here live as well, showing how they use EtcherPros. And to the community, remember to subscribe and see you next week talking about Balena blogs with some hardware hackers on the stream, hopefully.
All right.
I think that's all.
Sounds good. Mark.
Have a good weekend.
Yeah.
We'll have a good weekend, guys.
Bye, everybody.
Bye.
Bye, guys.
Bye.
Bye-bye.
Bye.